Final review: thermal analysis of fins to cool the small internal combustion engine. I am Dinesh D. Our team members are Balaji K. Kishorial, Nidhimannan M. We are guided by Mr. S. K. Nagurwali M. Tech, Assistant Professor, Mechanical Department, Tech. Abstract: a small single cylinder engine becomes very hot during continuous full load operation in summer season, resulting in piston seizing. The environmental factors considered in the design of engine are limited, since the ambient temperature considered is below the peak temperature encountered in the summer. Hence, during summer, the engine gets overheated that its endurance of the cylinder and liner material. Hence, to avoid the overheating, the cylinder and liner temperature are required to be reduced by the improved heat transfer. A cooling fan blows over the liner with fins. Constraints are that no additional cooling can be provided. Eventually, only the geometry of fin can be varied. Thermal analysis using conduction and convection is carried out. The increasing number of fins reduces heating. Introduction: heat transfer. Heat transfer is defined as the transmission of energy from one region to another as a result of temperature gradient. Modes of heat transfer: conduction, convection, and radiation. Conduction: when one end of the rod gets heated, the atoms in that get enlarged and vibrate during heating. The enlarged vibrated atom touch the adjacent atom and heat is transferred. Convection: convection is mode of heat transfer occurring due to temperature difference in a moving fluid, where the movement is created artificially or naturally. There are two types: forced convection and natural convection. Forced convection: it is a mode of heat transfer occurring due to temperature difference in moving fluids, where the movement is generated by external force. Free convection: mode of heat transfer occurring due to temperature difference in a moving fluid, where movement is generated by a buoyancy force. Radiation: heat transfer by radiation is defined as a transfer of energy between surfaces by means of electromagnetic waves, which is caused solely by temperature difference. Heat transfer from extended surface. Fins: whenever the available surface is found inadequate to transfer the required quantity of heat with available temperature drop, in convector heat transfer coefficient, extensive fins are used. Fins are used because of economizers for steam power plants, radiators of automobiles, air-cooled engine cylinder heads, small capacity compressors, electric motor bodies, transformers, electronic equipments. These are the different types of fin configurations. Engine cooling system: the high working temperature inside combustion engine causes difficulty in engine construction and operation. No known materials are capable of enduring continuously the high temperature to which the cylinder piston and valves are subjected, while at the same time retaining sufficient strength to withstand the high working loads. The temperature of gases in cylinder of internal combustion engine may be of 40 degrees Celsius or less on lower side and 2500 degrees Celsius on higher side. Such high temperature are not tolerable. Therefore, cooling systems are employed to maintain the cylinder parts at temperature lower than the mean gas temperature. Methods of cooling: they are direct cooling, indirect cooling. Air cooling system: Atmospheric air flows the east fins and the heat generated from the cylinder into the atmosphere. This type of cooling is used in scooters, motorcycles, automobiles such as mopeds, etc. The engine design become much simpler due to high average temperature in air-cooled engine. The warm-up performance of air-cooled engine is better since the temperature difference between cooling air and cylinder is high. Less amount of cooling is required. The control of cooling system is made easier. These are the advantages of air cooling system. Disadvantages: the air fan is an additional source of noise. Volumetric efficiency is lower. High specific output engine cannot be used. The volumetric efficiency is lower due to highest cylinder head temperature. Water cooling system. In the system, water jackets are provided in cylinder block and cylinder head, and water circulated in these jackets. Advantages: volumetric efficiency is higher. It can be easily installed in any vehicle rear. It can be easily installed anywhere in the vehicle. Disadvantages: need for radiator and pump increases the weight. It requires more maintenance. Warm-up performance is poor. Power is consumed by the pump. Problem definition and methodology. Problem definition: a small single cylinder engine 7.5 horsepower is getting heated during continuous and full load operation in summer season, resulting in piston seizing failure is reported. The cylinder and liner temperature is required to reduce by improved heat transfer. A cooling fan blows air over the liner with fins. Thermal analysis using conduction and convection is carried out. Engine and liner with fin. Engine specifications. Material details and thermal loads. Theoretical calculation for thermal stress. Calculation to find heat transfer coefficient properties of a flue gas at 125 degrees Celsius. Properties of flue gas at 112.5 degrees Celsius. Properties of flue gas at 120 degrees Celsius. This table shows the temperature, Reynolds number, Prandtl number, Nusselt number and heat transfer. Proposed design. ANSYS model. Circular fin model, circular fin meshing model. Circular fin temperature distribution. Square fin model, square fin meshing. Square fin temperature distribution. Square fin model with slot, square fin meshing model with slot. Temperature distribution for square fin model with slot. Result and discussion. From the above design and experiment and analysis, the following results are drawn. The design square shape with slaughter fin has higher heat transfer, has increased heat transfer surface and slits, which improves the heat transfer coefficient. The heat dissipation by designed fin square shape with slaughter fin is 32.2% more than the present design under constant over temperature. For constant heat flux, the fin surface temperature of design slaughter shaped fin is 120 degrees Celsius compared to 182 degrees Celsius. Temperature distribution of circular fin. Fin temperature at edge in degrees Celsius 181.797 degrees Celsius. Temperature distribution for square fin 131.475 degrees Celsius. Temperature distribution for square fin with slot 120.434 degrees Celsius. Conclusion. Due to environmental condition with respect to practical condition, three following temperatures are fixed. Minimum temperature 25 degrees Celsius, average temperature 40 degrees Celsius, maximum temperature 50 degrees Celsius. With help of minimum temperature, heat transfer coefficient H is calculated. For minimum and average maximum heat transfer factor is considered by assumption the maximum stress is more than the allowable stress, then the following conclusions are arrived. Provide temporary insulation by caps buffer layer of high composition material. References.